Good morning, I'm Elena Varnelli and I'm here to present you my master thesis activities. First of all, the main objective were the characterization of, through static tensile tests, of a new type of single lap interlock joint, introducing digital image correlation as a support of those analyses. The specimen tests were produced with laser-powered bed fusion aluminum and with a counterpart made of composite carbon fiber reinforced, pressed mechanically through the pin in order to achieve the joint. The different 24 we analyzed 24 specimens with 4 different type of geometry of pin geometries. We analyzed 8 rectangular, 8 cylindrical, 4 pyramidal, and 4 hourglass shaped. The tensile stress were performed using an instrument, and they lead us to achieve information about the maximum load condition that a specimen can carry. We can see from those 4 images they are representative of the 4 type of geometry. We can see in fact that the cylindrical and pyramidal achieve the maximum load capability, higher load capability, while the hourglass shaped are the worst of the 4 geometry. And using the offset method, we could calculate the elastic modulus, and once again, the hourglass shaped are the worst. For digital image correlation, we create a high contrast random pattern on our specimen, on the area of interest of our specimen, and this pattern called speckle is made of white dots on a black background. In this way, the software analyzes the interest area, subdividing in a grid and calculating the difference between the images of the single dots in order to achieve the displacement and calculate the displacement. The acquisition of the video of the specimen were made with a camera that record the front part and a mobile phone that record the lateral part. As we can see, we have recording the process. The process was useful not only for the digital image correlation, but even for the for us to better understand how this specimen behave under this specific load condition. So as we can see, there is an important bending in the aluminum part that lead to some stress in this area. For all the post-processing, we use the MATLAB as for filtering the tensile stress, for extracting frames, implementing digital image correlation using a open source software called Encore, and for processing image in order to create videos or GIF of the tests. While the we can analyze the first part of the plot, and we have the front one. We can see the fact that the strain gradients are we have strain gradients in corresponding of the line of the pin, while the lateral give us a better understanding of the distribution of the strain even in correlation with what we see before. The important bending is reported here as a strain gradient. So comparing all the information about one single specimen, we could have a lot of information about how the load is distributed on the part of the specimen and how it behaves under that specific load. So comparing all the 24 spacemen, we could understand better how the failure is. We can see for the pin with better penetration of the pin in the composite, we can see that all the pins are separated from their base. And we can see how the hourglass pins are pulled out from the composite part. By observing the fracture surface of our spaceman, we can see a common behavior, and this is the presence of a crack in the composite part corresponding in this line of pins, and it's common to all geometry. This is due to that that important bending that we saw in the previous slide, and the fact that aluminium goes into important bending broke the base of the pin and create this crack in the composite. During the analysis, we faced different type of error, like unwanted failure, where we have the aluminum plate that it's broken and it doesn't give us lots of more information about the specimen and the joints. We saw a slippage from the grips for this specimen, and this required to remake the tests, and we have a loss of information. In fact, in digital image correlation, where there is important separation between the two plates, we have the loss because in this region we have a high how I can say fluctuation of the data, and so it cut out this data. And then we had the sudden change in brightness that led to lots of error. In fact, the digital image correlation lost that contrast that helped it to analyze that frame. So we need to post-process all the images with to adapt to the first image's brightness. So at the end of this study, we could have validate the digital image correlation. We have defined some common behaviors, and we characterize all the mechanical properties of these 24 specimens. In this way, we have seen that the specimens with pin that are hourglass shaped aren't the best of them, of all the geometries, so we have to maybe exclude them from future iteration. And for the next step, all this geometry has to be all this specimen has to be tested under fatigue in order to understand how the operative life, how can they behave under operative life.